High in the driest desert on Earth, something extraordinary is rising from the dust. Engineers are constructing a machine so powerful it will let humanity see the birth of stars, the formation of galaxies, and perhaps the first signs of life beyond Earth. This is the extremely large telescope, and when complete, it will be the most advanced eye ever turned toward the cosmos. Welcome to one of the boldest engineering projects of our century. The location is Cerro Armazones, a remote mountain in northern Chile, standing over 3,000 meters above sea level. The Atacama Desert surrounding it is the driest non-polar place on Earth, with some areas that haven't seen rain in centuries. For astronomers, this barren landscape is paradise. Crystal clear skies, minimal humidity, and almost no light pollution make it the perfect window into deep space, far from the noise of modern civilization. Before construction could begin, engineers had to literally reshape a mountain. Using controlled explosions and massive earth-moving equipment, workers removed nearly 2 million cubic meters of rock from the summit, creating a flat plateau the size of multiple football fields. This monumental flattening took years to complete and produced enough debris to fill thousands of trucks. The result is a perfectly level foundation, strong enough to support a structure weighing thousands of tons. At the heart of the telescope lies its most ambitious feature, a primary mirror nearly 40 meters across. That's roughly the size of a 5-story building lying flat on its back, staring at the stars. No single piece of glass that large could ever be manufactured or transported. So engineers devised an ingenious solution. The mirror would be built from 798 individual hexagonal segments, each one a precision instrument fitted together like a giant honeycomb. Each hexagonal segment is a marvel of engineering in its own right. Measuring about 1.4 meters across, they're polished to an accuracy of just a few nanometers. To put that in perspective, if a single segment were stretched to the size of Europe, the largest bump on its surface would be only a few centimeters tall. These segments are produced in Germany and France, then carefully shipped halfway across the world to their desert home. The telescope itself is housed within an enormous rotating dome, standing 80 meters tall and weighing around 6,000 tons. Despite its colossal size, the dome can rotate smoothly to track objects across the night sky. Inside, the telescope structure resembles something out of science fiction, a vast cradle of steel beams and motors supporting mirrors with millimeter precision. Every component must withstand desert winds, earthquakes, and dramatic temperature swings between day and night. What makes this telescope truly revolutionary isn't just its size, but its system of 5 mirrors working in concert. Light from distant galaxies bounces from the giant primary mirror to a secondary mirror suspended high above, then through 3 more, each correcting distortions and sharpening the image. The final mirror uses adaptive optics, flexing thousands of times per second to cancel out the blurring effects of Earth's atmosphere in real time. Adaptive optics is perhaps the most magical technology inside this machine. Lasers shoot from the telescope into the upper atmosphere, creating artificial guide stars. Sensors measure how the atmosphere distorts the light, and tiny motors push and pull a deformable mirror thousands of times per second. The result is breathtaking. Images sharper than those from space telescopes, captured from the ground, peering through 50 miles of turbulent air with stunning clarity. Transporting components to this remote site is itself a logistical epic. Massive crates travel by ship across oceans, then by truck along winding desert roads that climb thousands of meters in elevation. Some pieces are so large they require special convoys, escorted slowly through the night to avoid traffic. The journey from European factories to the Chilean summit can take months, and every component must arrive in perfect condition, ready for assembly. The construction site operates almost like a small city. Workers live in specialized base camps, shielded from the harsh sun and freezing nights. Water must be trucked in, food carefully managed, and oxygen sometimes supplemented at high altitude. Despite these challenges, hundreds of engineers, technicians, and astronomers from across the world collaborate here daily, united by a single dream: to build humanity's greatest tool for exploring the universe. When fully operational, this telescope will collect more light than all the existing 8 to 10 meter telescopes on Earth combined. Its resolution will be 16 times sharper than the Hubble Space Telescope. Astronomers will be able to directly image planets orbiting other stars, analyze their atmospheres, and search for the chemical fingerprints of life. They'll peer back over 13 billion years, witnessing the first galaxies as they ignited in the young universe. The telescope is also designed to investigate some of physics's deepest mysteries. What is dark matter, the invisible substance holding galaxies together? What is dark energy, the force accelerating the universe's expansion? By studying distant supernovae and the motion of galaxies, this instrument may finally provide answers. It could even test whether the fundamental constants of nature have changed over cosmic time, potentially rewriting our understanding of physics itself. Construction officially began in 2014, but progress has been slow and methodical. Such a precise machine cannot be rushed. Each beam, each mirror, each electronic system must be tested rigorously. Delays from global supply chains and the pandemic pushed timelines back, but the project continues steadily forward. First light, the moment the telescope captures its first astronomical image, is currently expected near the end of this decade, a milestone the world eagerly awaits. The extremely large telescope represents more than just engineering. It's a symbol of international cooperation, with 16 countries pooling resources, knowledge, and ambition. In an era often defined by division, scientists from across continents have come together in this harsh desert to build something extraordinary, not for profit, not for power, but for understanding. It reminds us what humanity can achieve when we look upward instead of inward. Once it opens its eye to the cosmos, the discoveries it makes may shape science for generations. Children alive today could grow up reading textbooks rewritten by its findings. Perhaps we'll discover oceans on distant worlds, atmospheres rich with oxygen, or signs of structures we cannot yet imagine. The desert that once seemed empty will become humanity's greatest observation deck, a place where the universe finally comes into focus. From a flattened mountaintop in the world's driest desert, humanity is preparing to see further than ever before. The extremely large telescope isn't just a structure of steel and glass, it's a statement of curiosity, a monument to wonder. And when its first images finally reach our screens, we'll be reminded that even in the most barren places on Earth, our greatest dreams can take shape. Thanks for watching.